Hi, welcome to Maths with Shayem A. I am Shayem A. Please like, share, and subscribe. Let's get to today's lesson. Today we are looking at summing an arithmetic sequence. Summing an arithmetic Summing an arithmetic sequence. Summing means we are adding. So we are going to add terms of an arithmetic sequence. So when we add terms of an arithmetic sequence, we say this is a series now. We just say it's a series. It's now an arithmetic series. So when we see the word arithmetic series, it means it's still an arithmetic, but now we are looking at the sum. So we are going to see how we add an arithmetic terms. How can we add arithmetic terms? Now, one of the greatest mathematicians was in class one day and was asked to calculate the sum of the first 100 natural numbers. Sum of the first 100 natural numbers. Now, the learners were busy struggling, adding them one by one. Like, took their calculators and added 1 plus 2 plus 3 plus 4, like that. So they were supposed to add all the terms from 1 up until 100. That is the sum of the first 100 natural numbers. So now there was a prize for the learner who will finish first. Now, this particular student was looking at it, and while others were busy adding, trying to do whatever they were doing, so the learner looked at it and started pairing the terms 2 by 2. So he took the first term, which is 1, and paired it with the last term. So it's 1 plus 100. Took the second term and paired it with the second last, which is 2 plus 99, and did that for all the terms. So it's 3 plus 98 plus. The middle ones were 50 plus 51. Now he realized that all the terms are giving the same answer. So they were all giving him 101. So he concluded that it means the sum of the first 100 terms, it's because these terms now were 100 and they have been paired. It means now they are 50. So it means the answer is 50 of this 101, which gives 5,050. So whilst others were still struggling, he gave the answer that the answer is 5,050. And the teacher was so surprised. So now we are going to look at the same method. We are going to look at this method that has been used here to determine the sum to end terms of an arithmetic series. Right, let's generalize it. We want to add terms of an arithmetic series. So let's get the general terms. We know that the first term is A. The second term is A plus D. Like that. So Third term will be a plus 2d. So we want to add terms of another. So let's just say up until the last term. L stands for the last term. So it means a term before last will actually be L minus 1. And the term before the second last will be L minus 2. So we are going to add these terms. Right. So this we are adding the terms. Now we want to do what this guy did here. So we want to take the last term and group it with the first term like that. So, but here, because we cannot just do this, we don't know whether they are 50 or 70 or 20, we have to rewrite some n again, and now we start from the last term. So we will have the last term, a term before last, L minus 1, L minus 2, oh, excuse me here, it's L minus 1d, L minus 2d, so it's L minus 1d, L minus 2d, like that. So the last term here will be a, if we start from the first, a plus d, a plus 2d, like that. So now we are going to add the terms. So when we add equation, let's say this is equation 1 and this is equation 2, when we add them together we will get 2 of the sum n, and then we add these terms like that. So we will have a plus L, and then here can you see that the d subtract the d, we will still have a plus L, and even here the 2d subtract the 2d, we will have a plus L. Now it looks like all of them will give us a plus L. This is plus here. It's a plus L. All of them are giving us a plus L. But we are not surprised, because this guy here was getting 101, so he was getting the same value. So hence we also get a plus L, a plus L, a plus L, like that. So we will have all a plus L. So in other words, we will conclude by saying 2 sum L will be number of a plus L's. So we don't know how many they are, how many terms we are adding. So we just say it will be n of them, depending on how many terms we want to add. So it will be n of a plus L. Right. So in other words, our formula, if we divide this by 2, we will have sum n equals to n over 2 into a plus L. Now we have developed the sum formula for an arithmetic sequence or series. So this is the sum formula for an arithmetic sequence. Now, before we can even apply it, let me indicate that the L is the last term. We said that it is the last term. The last term is actually the nth term, is term n. And we said that the term n is a plus n minus 1d. So if we rewrite this formula, where we see the last term, we can even put a plus n minus 1d, so that we can have this formula as sum n is n over 2 into a plus the last term, which we said it's a plus n minus 1d. So if we simplify this, we will have n over 2 into a, rather 2a, a plus a is 2a, plus n minus 1d. So this is the formula for sum to n terms. Now, we can use this formula, the first formula for sum n, if we know the last term. But if we don't know the last term, we can use this one, when we have the value of a and d, so we can use this one. So that is how we derived the sum and formula. So you might be asked to derive the sum and formula in your test or examination, so take notice of this one. So you need to know how to calculate the sum to n terms of an arithmetic series. Right, we are going to take some examples where we calculate the sum of n terms of an arithmetic series. Let's take a simple example. For example, if we have 3, we want to add 3 plus 7 plus 11 plus up to, let's say, up to 20 terms. So we know that our A is 3 and our D, the common difference, is 7 minus 3, which is the same as 11 minus 7, which gives us a 4. So we can use the formula as we have derived it. We write the formula down. Sum n is n over 2 into 2a plus n minus 1d. So we want sum 20. So we're going to add 20 terms. So where we see n, we put 20. So we will have 20 over 2 into 2a, and the a is 3, plus n we said is 20 minus 1 times a d, which is 4. So this is a simple application of our formula. You can work it out with your calculator right away and get the answer, or you can just simplify and substitute. So in this case, 2 times 3 is 6, and this is 19 times 4, which is 76. So working out this is 82 multiplied by 10 is 820. So this is the sum to 20 terms of this series here. Okay, so we are going to look at something else that goes with the summation, and that is called the sigma notation. Now, this sigma notation is a Greek symbol. When we see this symbol, it's actually an instruction to add. We are instructed to add, so we are summing. So in other words, we need to be able to interpret this sigma notation. Now here, it's where the general term is, and here we are told where to start. With which term are we starting? For example, if it's 1, it means we are starting with 1. And here we are looking at the number of terms. So for example, if we want to add 20 terms or up to 20, it means it's going to be 20 there. So we are saying here it's up to how many terms? And this is the general term. And this one indicates where or with which term number to start. Okay, now we are going to look at a practical example. So we have a sigma, and then we are putting a 20 here, and we have a general term, it's 4r minus 1, and we are starting from 3. Right, now we are expected to add terms from substituting with 3 up until substituting with 20. So we substitute r with 3 and we count upwards up until 20. So we are going to add all those terms. Now, the first thing that we do when we see a sigma notation, we need to expand it. We need to see the terms, expand them, and then so that we can be able to see what type of a sequence or a series we are dealing with. For example, if we put the first term, we start substituting with 3, we'll have 4 multiplied by 3, which is 12 minus 1, which is 11. So let's substitute practically. We have 4 into 3 minus 1, that is the first one, and then we also substitute going up. So it was from 3, now we go to 4, so it's 4 times 4 minus 1. The next one, if we can have the first 3 terms, so it will be 5, so it's 4 times 5 minus 1. We can even go to the last term where we substitute a 4 times a 20 minus 1. Now, if we expand this, we will have, as indicated, this it's 11. 4 times 4 is 16 minus 1 is 15. And then 4 times 5 is 20 minus 1 is 19. 4 times 20 is, this is the last one, 4 times 20 is 80 minus 1 is 79. So it means that in this question here, we are expected to add 11 plus 15 plus 19 plus all the terms there up until plus 79, which is the last term. So because we realize that it's an arithmetic series, if we check the common difference there, 11 minus 15, if 15 minus 11, we get a 4, and 19 minus 15, we get a 4. So this is an arithmetic series. So we are going to use sum n of an arithmetic series. So it's n over 2 into, we have both a and d. We also have the last term. So we can use the easy one that requires the use of the last term. So we can use this formula here because it's easier and faster. So we are going to use it. But even the other one, you can use it if you want. So we can just write a plus l. Right, so now the question is, how many terms are we adding? We want to know what this n is. All right, so we are moving from 3 to 20. So you can count from 3 to 20 how many terms. But the easier way to always know how many terms you are adding is to take the 20 and subtract the 3 there. Take the top one there, which is 20, subtract the bottom one there, which is 3, but always add 1. This is very, very important. You must always add 1. So in other words, what we have, 20 minus 3 is 17 plus 1 is 18. So it means the terms are 18. So if it was 1, for example, if it was 20 and here it's 1, you will still have 20 minus 1 plus 1, so there will be 20. So if it's 1, it's easier. But if it's any other number, then it becomes a little bit of a challenge. So you must be careful of this. So because it's 3, it means to know how many terms, we'll just take the 20, subtract the 3, and add a 1. So if you want, you can count them one by one. You'll realize that there are 18. Remember, we are starting from 3 itself, so we are counting this. We are not starting from 4, because if we were starting from 4, there will be 17 terms, as some of you might try to think it's 17, but we are counting even the number 3 there. Hence, we have substituted the 3, which we get 11. So there are 18 terms. So it means we are going to add 18 terms. So sum 18 will be 18 over 2 into A, it's 11, plus the last term we have counted it to be 79. So you see this is it's easier, so you can work it out, get an answer right away from your calculator. Okay, you can even simplify it. 18 over 2 is 9, and then 79 plus 11, it's 90. So now it's easier. You can just get your answer from there. You can use your calculator and get your answer. You could even get your answer right away from just the first step. So, but 9 times 90 is 810. Okay, we are now going to take another example involving the use of the sigma notation and sum n formula. We are just taking an example here. Let's say we have this 7 plus 10 plus 13 or let's write it as a sigma notation. Okay, plus up till n terms. So they're saying this is less than 120. So the question is, determine the largest value of n. Let's write it down. Determine the largest value of n such that this, let's write it in sigma notation, such that we have n here, we have k equals to 1, and we have 3k plus 4. So this is less than 120. Let's look at this question here. Determine the largest value of n such that this is less than 120. So we said that the first step is to expand. So when we expand, remember we start with substituting k by 1. So 3 times 1 is 3 plus 4 is 7. So it gives us this 7 here. When we put a 2, we have 3 times 2 is 6 plus 4 is 10. So it gives us this 10 here. And third term, we put a 3. 3 times 3 is 9 plus 4 is 13. So it gives us this. So this, it's actually what we have here. So we expand it and we get this expanded notation there. So now the question is the largest number of terms. We need to know how many terms that we can add and we get an answer which is less than 120. So we know that if we add 7 plus 10, the answer is less than 120, it's 17. So that is why the question is the largest. So if we 7 plus 10 only, it's actually the lowest. So we want to know the largest number of terms such that when we add this, the answer is less than 120. So the important thing here is to be able to understand the question. What happens if we add 7 plus 10 plus 13? It is still less than 120, but it's not the largest. So we need to understand. We want the largest number of terms that after we have added, we will get a sum which is less than 120. Okay, so we said this is an arithmetic sequence. So we are going to use the sum formula, which is n over 2 into 2a plus n minus 1d. So this must be, when we add this, it must be less than 120. Right, this is one of those challenging questions. We need to be careful when dealing with this type, but it actually becomes easier if you can just understand it. So n, we don't know, we are looking for this n, so we have n over 2 into 2, the a is 7, it's term number 1 there, and then this n we are looking for, d, we have already calculated d, or it's 13 minus 10, or 10 minus 7, which is 3. So this must be less than 120. Okay, so now if we simplify this, we have n over 2 into 14, 7 times 2, and then removing these brackets there, we have 3n minus 3. So this should be less than 120. Now if we simplify this, it's best that we multiply by 2 both sides, so that we can have in the bracket we have 3n plus 11, 14 minus 3. So we are left with n here, and then this is less than 240. Right, so removing this bracket, now we have 3n squared plus 11n. So let's take the 240 that side, it will be minus 240. So this is less than 0. Okay, we want the factors. So in this type of equation, it is always easier to use your formula, quadratic formula. So n is, you remember it from grade 11, it's minus b plus or minus the square root of b squared minus 4ac all over 2a. So we substitute that n equals to minus 11, the b is 11, plus or minus the square root of 11 squared minus 4 times a is 3, and c is negative 240 all over 2 times a is 3. All right, so now we getting the values here using our calculator. We get a negative 10,9 if you press your calculator there, or we also get a 7,3 if we round off this. But these are not really the values of n. Remember, this is less than, so, and because it's less than, we need to understand and remember that these are just the critical values. Critical values, they are not really the answers to our question. So in other words, if they're critical values, remember how we deal with inequalities. So we will put the negative 10,9 here, and we have the 7,3 there. So remember, it's less. Our question is less, so it means it's below there. So it means our answer n, it's actually between minus 10,9 and 7,3. Now we can go back to our question. If we understand sequences or patterns, n will never be a fraction. So it means n is an integer. So it can't have commas. So that is why this answer is just saying n is between negative 10,9 and 7,3. Now, let's go back to our question. The question is, what is, determine the largest value of n such that this is less than 120. So when we add the terms, the answer must be less than 120. So here we have an answer that n is between negative 10,9 and 7,3. Therefore, because n must be an integer, it means therefore that n will be 7, because now it must be less than 7,3. So it means the highest or the largest value of n is 7 here. So remember, we wanted the largest. So what does that mean? It means if we can add 7 terms of this sequence that we had, the sequence that we were given here, if we can add 7 terms, the answer will be less than 120. So you go and try that on your own and see the realities of what we are doing. So meaning, if we can add more than 7 terms, meaning if we add 8 terms, the answer will be more than 120 now. So hence we are saying the largest value of terms that we can add is 7. So that's our answer. So we have answered the question. So the largest value of the terms that we can add is 7. So guys, that is how we use the arithmetic series. That is how we add the arithmetic series. So now we will meet again with the next lesson. Thank you. Don't forget to like and subscribe.